Okay, this is lesson 10B on combinations. So far we learned about permutations where order does matter. So here we have a different scenario where we have order does not matter. Okay, and that's the key thing here. And we basically use a standard setup, and it's called NCR, and a lot of times we use the word choose. Okay, we use pick for permutations, and I'll use choose for combinations. So we'll put choose here as a reminder. Um, and notice the n factorial over n minus r factorial. That part right there is the same thing as NPR. Okay. The only thing that's different is right here we are dividing by r factorial. And again, r is the number of positions. So let's say you have two different scenarios where you have permutation versus combination. Permutation is like you have 5 people in a race and you're looking for how many different ways can you finish first, second, and third. So that would be 5P3, okay? Because you have first, second, and third place. Now let's say you have the same 5 people and you're looking, for instance, to go down state and you need the top 3 finalists. So it doesn't really matter if you finish first or third, as long as you're one of the top 3 finishers, you still advance to the next level. So this is called 5 choose 3. And really what it is you start with 5 pick 3. So again, let's figure out what that number is here. So I go to my calculator and I go 5 math, go over probability, um, 3. And there's 60 ways for this to happen. Okay, so let's go ahead and write that down. So 60 ways for that to happen. So this is the same thing as 60 ways, but then we need to divide by, well, how many ways can you put in order first, second, third place for the same 3 finishers? So let's say it's Peter, Paul, and Billy. Peter could be first or it could be third. That'd be a different arrangement. So there is 3 factorial ways to arrange the top 3 finalists. So you need to divide by 3 factorial, which is obviously 6. So 60 divided by 6 is simply going to be 10. So there's really only 10 groups of finalists. So we'll see combinations when we talk about groups, committees, anything, if you're picking a like basketball team, or it doesn't matter who get picked first or last, as long as you're one of the starting 5. Okay. Now the other thing that this lesson is going to focus on is putting by multiplication several pieces together. So let's take a look at some of those examples here. Okay. And then I'll show you on the calculator some things too. I'll probably do the first 4 here, and then you can look at the last 6. 10 people enter a contest where first place is a car, second place is a $100 gift card, and third place is a bowl of cereal. How many different orders can the contestants finish first, second, and third? Well, that's really simple. This is where order is important. So we have 10, pick 3. Okay, because obviously first place is a car, third place is a bowl of cereal. Clear difference. Okay. Um, this one same scenario where first, second, third all win a car. How many different ways can the contestants finish first, second, third? Let's change this to the wording to say how many different orders can the contestants finish winning a car? Okay, so how many different ways can you win a car? Well, it really doesn't matter if you get first, second, or third. So I'm going to say 10, choose 3. Okay, so there's the difference right there. Another clear example. Okay, 13. I'm sorry, number 3. 13 people are running for a race for a 5-person high school leadership committee. So right there is the key. How many different ways can a committee be chosen? So we have 13, choose, and again, 5 people, 5. Okay. Find a number of ways 5-card poker hand that becomes a standard deck of cards. Okay. So there are 52 cards in a deck, and you are choosing 5 at a time. Okay, and again, that's a good example. We're talking about if you're dealing like poker cards, you deal one at a time. But once you get into your hands, you can rearrange them. So the order that it's dealt to is unimportant. Okay, let's take a look at 5 and 6 here. Uncle Steve's Pizza offers 10 toppings. How many different ways 3-topping pizzas are possible to order? Well, again, the order that the pizza's made doesn't matter if the mushrooms go on first or the pepperoni. So we're talking 10, choose 3 once again. Um, You have 6 friends, but you can only take 4 skiing with you. How many ways can that happen? Well, it doesn't matter the order you pick the friends. It's a group of 4 people. So we have 6, choose 4. Okay. I'm going to go ahead and forward to another problem here. And I'm not worried about this more at least, or at most problems at the bottom. We'll cover that later on. But let's take a look here at uh, number 3. 3 is a really good example showing how to put multiple combinations together. All right, so a basketball team has 3 centers, 4 guards, and 4 forwards. And how many ways can a coach pick a starting lineup that consists of a center, a guard, and 2 forwards? So when you look at these things, you want to put together groups. So here we have guards, forwards, and centers. And you want to look at all possible choices. There are 3 centers to choose from, 4 forwards. I'm sorry, got these in the wrong spot. 3 centers should go over here. There are 4 guards, 4 forwards, and 3 centers. And again, the order that's chosen, not really important. So these are all choose, choose, choose. And we're picking 2 guards, 2 forwards, 1 center. And the key here is that for every 1 guard you pick, there's different combinations of forward centers, which would be a different group. So you're going to multiply these. This is like picking pants, shirts, and shoes. How many different, outfits can you put? So again, in my calculator, what I'm going to do is, let's go ahead and turn this on. I'm going to clear this, and I'm going to type it in simply here, same way. I'm going to do 4 math probability, go to choose 2, and then I'll multiply it by the same thing, 4 math, and multiply it by 3, choose 1. And notice there's the 3 things separated by multiplication symbols, and we have 108 as our answer. Okay. So those are things that you want to look for. Okay. And that's really about it for this lesson right here.